What's going on, everybody? Today we're going to be taking a look at PuLP, which is a Python library used for linear programming and mixed integer programming. It allows you to define problems and solve them using various solvers. However, before I show you that, I'll show you how we can manually solve this problem using pen and paper. But in this situation, I'll make it easier by using Python to show our work manually. So just imagine you're using pen and paper to perform the following work to get a solution. From this problem, and the problem is right here, so you guys can read it. So a Texas barbecue company receives and sells $34 per pound of brisket and $30 per pound of ribs. The cost per unit to prepare each pound of brisket and ribs are $5 and $4 respectively. The monthly 30-day cost must not exceed $27,000 per month. If the preparation takes 5 minutes to produce a pound of brisket and 15 minutes to produce a pound of ribs, how many pounds of brisket and ribs should the company make to maximize profit? Determine the maximum profit the company earns in a 30-day period. So we have to figure out what the objective function is. So we'll go ahead and put it right here in Markdown. So the objective function, so we're trying to maximize profit, we're trying to maximize sales because the monthly cost limit is limited at $27,000 per month. It's fixed. So really we need to maximize sales, and from there we could easily get the profit. So the objective function, I'll just write it right here. S, we would just stands for sales. B, brisket. R, ribs. So those are the variables. So that's the objective function, and the first constraint equation is going to be $5B plus 4R is less than or equal to $27,000 per month. The next constraint equation is going to be the time. But in this situation, it says 30 days. So it's less than or equal to 30 days. But here, it's 5 minutes and 15 minutes. So we need to find out how to get 30 days to minutes. So we could just easily do that and I could show my work here of 30 days times 24 hours times 60 minutes. And so that would appear on the right hand side. So we can write the equation. Write the equation to be 5b plus 15r is less than or equal to 43,200 minutes. Now, here are our equations: the objective function, the two constraint equations, and we want to make a graph. We want to make a graph with the intercept equations. So don't worry about this. It's just Python code to create that graph. So these are the two inequalities, and to get these intercepts, we would substitute 0 in for either B and R. So for example here, if we set B to 0, to solve this equation, it would just be 4R equals 27,000 divided by 4, and you find that R value. And that's what we did here when we found these intercepts, and right here as well. And this shows you these corner points right here. The area shaded under here, under the two lines, that's going to give you the optimal the optimal value that we're looking for as far as pounds of brisket, pounds of ribs. So we're going to analyze these 3 points, and just to check, I'm going to run a system of equations and check that B is equal to 4,222 and R is 1473. So if you're solving this by hand, we would need to get a table and substitute these values into the sales equation and figure out which one is the greatest value. So in this situation, B is equal to 5,400, R is 0, 0, 2880. So these are the corner points right here. But what we solve for, we would substitute that in here. And then we would substitute these values into this objective function. And that's how we're going to get these sales. So based on that, the profit would just be the highest value that we see here, which it's going to be that point, 187,738. Let me subtract that from the given constraint, $27,000. And that would actually be your answer, $160,738 in profit. So now that we've seen this work needed to solve this problem manually, I'll show you how to use the package PuLP to expedite the process of solving this. So to install PuLP, an option would just be to go to your terminal or command prompt, type in pip install PuLP, but we could do it here in Jupyter Notebooks. I'm just going to show you just for example purposes, but I already have it installed, so it's going to show you that the requirement is already satisfied. So now let's initialize a new cell here and import the package. Let's go ahead and run that. First, let's initialize the linear programming model by go ahead and defining a variable. So what I'm doing here is setting that variable prob is equal to LP problem, which is just syntax in the PuLP library. The first argument in the function is problem 1, and that's just what I'm naming it. And the second argument specifies whether it's a minimization or maximization problem. So in this case, we're trying to maximize profit, or maximize sales. So we go ahead and put LP maximize. The next step is to define the decision variables. And I'll go ahead and put that in the same cell. So I named the variable x. Everything looks good. I named the variable x, and I use the function LP variable dot dix to start including the variables. The first argument is a string with just the name of the variable, and I just named it x. The second argument is a list with the named x's. So since we only have 2 variables, brisket and ribs, 1 will stand for brisket and 2 will be for ribs. The next argument is the lower bound. Our decision variables are positive, so we must write low bound is equal to 0. The final argument is the category of the variable. The options are binary, integer, or continuous. So in this situation, it's going to be continuous. So just to check, we could print out X to see all the decision variables. So we could run that. So here we have the dictionary with the decision variables X underscore 1, X underscore 2. And then the same cell, we could add the objective function. So this is just the equation that we knew from above as the objective function. And we can go ahead and check it as well by printing it. Go ahead and run that. And then you can see again, what we printed previously, and the name of the problem, trying to maximize the objective function and the two variables. Now it's time to add the constraints, and to add constraint 1, we go ahead and kind of do the same process. So here we got the 5b plus 4r less than or equal to 27,000. And then the next one, 5b plus 15r is less than or equal to 43,200. And we could solve this now that we have everything. And we could run this. And the output's going to be 1, which means the problem is optimal. But we could look at this from a different lens. So let me see. So I'm going to set a variable to status, perform the solve method, and print the status. And here it's going to say optimal, which basically just says they found an optimal solution to this. So 1 and optimal, kind of the same thing. If we want to find out the values of the decision variables, we'll go ahead and do that in a new cell. So we have for loop, iterate through the variables. And this is going to be a nice way to give the variable name along with the value. So here we have b would be equal to 4,221 and r 1,472, which these are the same values that we got by performing the operation manually. And from there you can plug those numbers. Since those are the optimal variables, we plug that into the objective function to figure out the maximum sale, and just do the same process to find profit, and then you have your solution. So this is just a way to show how we can use Python to expedite the process of solving a linear programming problem. And with that, thank you so much for watching.